Hello, and this time we're looking at constructing simultaneous equations. Now this is very much the next layer of skill from solving equations, and although they're sort of different in that you could set them up and not be able to solve them, and you can solve them but not be able to set them up, it usually follows that if you don't know how to solve simultaneous equations, you're going to struggle with the constructing. So if you're not too happy with things that, 2x plus 3y equals 15 and 5x minus 4y equals 12, if that kind of question is beyond you, then maybe check out one of the other simultaneous equation videos where we talk about how to solve those, because otherwise this might be a step too far. And if you're working towards GCSE work, exams, or just working through the content in Key Stage 3, I would strongly recommend that you spend your time on solving the equations first, and when you're quite confident with that, then you look at setting them up. So let's go through these two examples. There's not much I can say as to how to do this, but maybe going through the examples will give you an idea. Essentially what we're looking for, because we know it's simultaneous equations, is we're looking for two relationships that we can pick out of the words. Now if it's a diagram like this, then we might be able to do it based on the shapes, and we might be able to do things like that. But if it's just words like this, there'll be two things that they can give us, a total or a comparison of costs or something like this. So let's have a look. 2 compact discs and 4 DVDs cost £60. Well, that is an equation right there. If we put C as the cost of a compact disc, assuming that this assumes that compact discs and DVDs cost the same, of course, which might not be the case, but we'll say it is. And we'll say that D is the cost of a DVD. Then 2 lots of the cost of a compact disc plus 4 lots of the cost of a DVD tells us that that adds up to £60. And then the second equation, it just tells us nice and straightforward that we've got 5 compact discs and 3 DVDs with a different total. So again, we can just write that down. 5C plus 3D equals 66. And that's it. We've just picked out the numbers from the words, and this question's been quite nice because it just told us the amount of stuff and the total, and so we can just write that down. Sometimes, usually more A-level questions, you have to, they don't sort of make it so obvious, and you have to think, well, I know that maybe it's probabilities, that if I add all these probabilities up, it'll be 1 because it's an exhaustive list, or something like that. So you might have to use information that you know around the question. I'm not going to go through how to solve these. We're not going to go through that because that's in another video, but this is one where you'd have to multiply both equations up by a certain amount to make either the C numbers the same or the D numbers the same to then cancel it. Setting up the second one, the perimeter of this rectangle is 22. What are its dimensions? Well, in this one, you do need to have a little bit of knowledge about a rectangle and about what perimeter is. So we know that perimeter is adding up everything around the outside, and we know that that's 22. So we can do that. We can say, okay, so that is 8 plus the other 8, so that's 16, plus these two sides added up. Well, that's x plus 2x, so that's 3x in total, and 7y minus 2y is plus 5y, and all of that added together we know is 22. Now, as we know that we want it in this sort of form up here, where we've got x's, y's, and the answer, we could take off this 16 and make it look more like what we're used to. So 3x plus 5y, take 16 off both sides, and that's going to give us 6 on this side. So that looks good. That's looks like what we're aiming for. But where can we get the other equation for? They haven't told us anything else. They'd have told us the area. We could have done one of these times 8 and got the area, but they haven't told us anything. So this is where we need to know something about the situation. And in this case, it's a rectangle. So we know that this side here is the same length as this side here. So we can actually just say, well, this algebra must be the same value as this algebra. So x minus 2y equals 2x plus 7y. And if we then just rearrange this, same as we did here, with all the x's and y's on one side, we will take away an x from both sides. So 2x, take away the x, is just an x. The 7y, we're going to add the 2y, because we've got to do the opposite. We've got to move it over to the other side and do the opposite. So that's going to be plus 9y, and that leaves nothing on the other side. That leaves 0. And here are our two equations now. 3x plus 5y is 6, and x plus 9y is 0. And again, now it's just a case of solving it. And this one we can just scale up the second one to match the 3x and cancel those. And again, that's the actual mechanics of doing that is another video. But hopefully you can see how we've set the questions up from the information that they give us, if they're kind and give us two sets of information. But sometimes we might have to use information we already know, like, the fact that opposite sides of a rectangle are equal, or the fact that we had to know what the perimeter was, and things like this that they assume that we will know, and we will spot those relationships that will give us the second equation. If there's anything there I haven't explained clearly enough and you want to ask a question, you can pop them down in the comments. But otherwise, ta-ra for now.